All right, we're back. Okay, so I want to talk to you guys today about hypothesis testing. We started getting into the kind of the concepts that we're going to be making use of when we were doing confidence intervals. So what have we talked about so far? Let me get my pen up here. Try to focus more on explaining the intuition to start. So just listen up and hopefully this will make sense. Sometimes it's kind of confusing. Alright, so what we did with normal distribution stuff, this was how to deal with statistical problems really like this. We broke it into 4 steps, right? First one was take the question and turn it into a picture. Once you do that, then you have something to work with. You know what you're trying to find. I always gave you something that looked like this, right? Where you have mu, x, sigma, or p, 3 of the 4, and you need to find the 4th one. A lot of the stuff we did at first was finding x or finding p. You did one problem where you had to find sigma, and then confidence intervals essentially are each 2 problems where you have to find mu. Okay. Step 2 is then relate your picture to the standard normal distribution. Right, so you take your picture and you relate it to this one, 0, 1. Once you do that, this will either kick out a p, like some area under the curve, or a z. You have one of them. Then step 3 was use p to find z, or z to find p, depending on what you had. And then sometimes that involves a score function, x minus mu x over sigma x. Sometimes it involves your z table, which is where z's and p's are related, right? And then last but not least, you answer the question. So you go back up to the question and give the answer. Helps to reread the question to make sure you're getting what you want. So all this stuff was exercise to get you familiar how we think about probability, to get you familiar with finding areas under a curve, using a table, that kind of stuff, because that's the kind of stuff we're going to be using. All this stuff deals with probability. All right, we complicated things a little bit with sampling distributions. Not a lot, just a little bit, right? Because what we said was, okay, this stuff is all good and well if you know that your population is standard or is not standard normal, but is normally distributed. But in practice, we don't think there are that many populations that are normally distributed, right? There are some height, IQ, but that stuff is great if your population was normally distributed. Fortunately, what we found was that the population of sample means and sample proportions for that matter is always normally distributed. So all that stuff was useful to us for that reason. Right? The population of sample means is normally distributed. So what we did here was we said, okay, well, this really only gave us a little bit of trouble because we said, okay, well, the sampling distribution of x bar is normal with a mean of mu x bar equals mu x, so that's right here, and a standard deviation sigma x bar equal to sigma x over the square root of n. So for a long time we did problems where they just, instead of giving us these 3 of these 4 things, right, they just gave us the stuff we needed to get there, right? And then we went right back to, that was all part of step 1, really. We just used that stuff to draw a picture. Okay, so we practiced these so we could get good at it. But again, in this case, they gave us stuff we knew. Okay, right? We pretended we knew the population distribution. Pretended we knew mu x and sigma x. That's an unreasonable assumption. So then we moved on to confidence intervals. And we started dealing with, and not explicitly, but when we moved to confidence intervals, we started dealing with hypothetical sampling distributions. Right? We had a weirdly high one and a weirdly low one, right? And what we were looking at was which values for the population mean would give us x bars that looked odd in one direction or the other. So those were dealing with hypothetical sampling distributions. now what we're going to do is we're going to refine that a little bit further. We're going to take advantage of some results from logic, and we're going to use that to make inferences about the way the world really works. So, how does this work? It's pretty cool. The way it works, first of all, is that we have a stated or maintained belief. Right? That's what this is about. This is about belief. It's a very precise way, very accurate, or not, yeah, very precise way to deal with belief. This is our stated maintained belief we call our null hypothesis. We denote it H0. So H0 is our belief at the beginning. It's the thing that gets the benefit of the doubt. What we're going to do is we're going to test this belief. We're either going to reject it or fail to reject it. But we're assuming it's true. What we're going to do is we're going to assume it's true, and we're going to see if it is. Right? So we'll assume that H0 is true. Then we're going to collect some data, and then we're going to say, this is what hypothesis testing essentially always is. What is the likelihood that my null is true and my sample mean, or whatever, my population, my sample parameter, sample result exists, right? So if my null hypothesis was there's nobody who lives in the city of Little Rock, right, or there's less than 10 people who live here, and then I took a sample of 1 square mile of Little Rock and I said, wow, there's more than 10 people right here, then I would have to say my null hypothesis was totally wrong. I'm going to scrap it. And that's the intuition of hypothesis testing. We're very careful about stating a belief, okay, and then we take that belief and then we see what the probability is that we would get our result if that belief were true. The way this works in practice, to make it a little bit more complicated, is that we draw the sampling distribution under the null, and then we use that sampling distribution to come up with a probability. So this is the distribution if H0 is true. Then we find out how likely our sample is. And if it's really unlikely, the null is just an assumption, but the sample is something that we've seen with our own eyes. So if it's really unlikely, we have to scrap. We reject H0. That's what hypothesis testing is. Really not that complicated, right? It can be complicated to try to apply this, but the intuition is pretty sound. We take a belief, we play out all the implications of that belief, and if it turns out that it's just unreasonable, then we scrap the belief and we in favor of something else. Okay, so the steps of hypothesis testing. Let's break it down into steps. Got about 5 minutes left and I can lay it out for you. The first one we're going to do is we're going to develop our hypotheses, which means coming up with a null, which is our null. It's our maintained belief. It's the one we're testing. And we'll practice a fair bit with how to state these precisely. And coming up with an alternative, which we'll accept, or we'll accept in the alternative if we reject the null. Okay, that's step 1. Step 2 is choose a level of significance. So how unlikely does our sample have to be for us to reject the null? We choose a level of significance, which we usually call alpha. And this is our severity of disbelief, something like that, right? How skeptical do we want to be? Be careful in selecting this. Again, we'll talk about this more later. Step 3. Step 3, for now, this will be simple, but this part gets harder later. We choose the appropriate test statistic. And a test statistic will allow us to. So what is a test statistic? What's the easy way to say this? An intuitive way. A test statistic it's a characteristic of our sample with a nice distribution. By nice, I mean we can look it up on a table. In particular, we can look it up on a table and find out how unlikely this particular sample is. Right? That's what it is. Usually it tells us how many standard deviations away we are, but the more important thing is that this test statistic tells us, or can be used to figure out how unlikely our sample is. All right, step 4, collect the data and compute the test statistic. We don't usually collect the data that much in this class, but in practice we do this. We compute the test statistic. This means plugging in the actual sample values. And so the test statistic is usually a formula. And then we use our sample data to calculate it. And then we go to step 5, which is we evaluate the test statistic. Okay. Now I'm going to, in a new video, I'm going to post relatively soon, maybe right after this, I'm going to go through and explain how we go through each of these steps and what they're like. But these are ultimately the five steps. Real quick, evaluating the test statistic means find out how likely our sample is and decide what to do about our hypotheses. But yeah, so we'll walk through each of these. We'll do some practice problems. You'll have some stuff. Yep. So if you have any questions, please let me know, and I'll do my best to answer them. Hope you guys are well, and more soon on hypothesis testing.